Okay. Okay. Thank you, Daniel. Okay. So this is the idea. All the materials are on a GitHub repository. I will show you how you can access that. But before we move into that, let's demonstrate a little bit how you can access the cluster. So here, let's see, I think it's on here. No, here, I think down here. Okay. There are several ways for accessing the cluster. Today, for this particular workshop, we require interactivity. So that's the whole purpose of this. So we will not be using the SSH interface. By the way, this workshop is a little bit particular because we will be using the cluster just for convenience. But if we are not supposed, let's say, the kind of things that you will be learning today apply out of the HPC context. It's just for creating offering interactivity. If you are planning, for example, for a lecture, and you want to offer a material where people can interact with the different elements. So joined text, eventually equations, tables, the math and the simulation all integrated, and allow the users to offer something that is cool and attractive, and invite exploration. So there are basically several users that I have in mind for this kind of workshop. One could be high school teachers or people responsible for creating lectures at different levels, and they want to integrate some interactivity into the classroom. That's one option. Another use case, put it that way, could be researchers who want to offer a seminar or something, and they want to present that seminar beyond the traditional slides, which are very passive and the people will just sit down and listen. Instead of that, you can integrate a web application where people can explore your data, can explore and get it, start playing with your research, with the data that your research is creating. So that is also more engaging also for that kind of audience. And finally, is for taking data that you produce during research and you have the paper, and don't keep that data or let the data die, let's say, after the paper was created, but enhance it with applications where other collaborators, other users could go and start playing with the data, start exploring all the different things, all the kind of things that you never show on the paper because you don't have enough space and you have limiting plotting capabilities, or how many plots you can put on the paper. So you can instead create an application. That application could attract or could bring more impact to your paper, to your research, and that will return to you in many ways. So all those use cases, that is the kind of things that I will be showing today and the next week, and then for the second session. And we will be using Open on Demand simply because we have the tools there on the machine we'll be using. So how we use Open on Demand, for those who have not attended the first workshop, the first session. This is the idea. I will be doing with you. You can see the instructions here, but I will do it myself. So I will be following all of this to go to Open on Demand. So first thing, go here on demand, tf.hpcwvu. After that, you receive this, you are greeted by this interface. You put your password and you enter your Duo authentication. Okay, so we are in this. Now, the first thing that I would like to do is to download the material. You can do it. You can do it at home if you have at home your own Python, if you use to Python. By the way, this version assumes that you know a little bit of Python, but I will introduce things softly. I will, so you can follow if you are not super familiar with Python. I will introduce the elements with a few examples first, and so it could be soft. It will be soft. Well, so the first thing that I need is to download the materials, and for that, what I did was clicking here in clusters, and after you click Torny flat, and you get here a terminal. And I think I can do it here. Let me see. Well, what I will, let me see. I might put here. This is small, really small. But I think I can do it here. It will be easier. Git clone. I type git clone, and I put on the chat. Let's see. The location where you can download all the materials. I will paste the whole command on. I hope I can paste the whole command. See if that works. Oh yeah. So here it is. With this, you have all the web pages, but that is created in another. So you can go here to this to the first lesson here. Well, our lesson page, and all is here. But you can use this website, and you can follow the material with the website. But now, let's start with the first notebook that I have to present. I think it's here, interactive in code for China. Well, yeah, I will start with this. So now, the next step is to have a web interface on a virtual desktop here on demand. So for doing that, you just click here, or you click here on Thorny desktop. It will create a desktop, virtual desktop, that it will be running on one of the compute nodes. We will not be using any extreme computation. So how many we are here? 18. So yeah, you can request for 4 hours, a couple of hours actually, 2 hours, 4 cores, it will be enough, and that's it. So if with the extra cores, we devote some extra processing for the user interface, and we have a couple of cores for the actual calculation. So it will be fine. Let me see if I can extend a little bit the quality. This is because with Zoom and all that, it will be. We'll try to make it a little bit better. Yeah, I think it's okay. It's okay. So now, what I did now was opening a virtual desktop. This virtual desktop is not taking significant resources from your computer. Everything that we'll be doing, it's happening on a remote machine. We just need a machine that has the packages that we will be using and a web browser. So that's what I will be doing here. I will be splitting. I will be opening a terminal here. I will probably stretch a little bit this terminal around here, and I will be opening a browser here. I need both things. Okay. So that's my layout here. I will be entering commands on this side. I will be looking at what I will be creating on this side. And this is important because I will be going back and forth between the applications that we are creating and the result that they produce when we launch the application. So let's put a little bit, let's try it first here. Okay, the first thing that I will need is to load Python, a version of Python that will help us here. For those of you that have not attended the previous workshop, there is a way of loading software packages on a cluster, and it's with environment modules. So you just type, as I'm doing here, load lang Python. That should be enough. It will load the latest version of Python, and that I hope will contain all that I need for this tutorial. After that, I can just launch Jupyter Lab. And I am doing this. There are better ways to do that, and at least for the Jupyter notebooks here, or not, more direct ways. So if you want really a Jupyter notebook, a pure Jupyter notebook, you just go here and open the Jupyter notebook. This is one way, and actually you can probably do that to demonstrate this. So in that case, I will just click in here and say 4 cores, no GPUs. And this way I will be creating a Jupyter notebook, Jupyter Lab session out of this desktop. This desktop I really need for Shiny for the first software package that will be exploring, but it's not necessary for my first discourse. My first introduction could be on just a Jupyter Lab session. So I will be probably starting this way. So I will be going here. If you download the data, you should have the data there on the repository, and I will be opening Shiny, and I will be opening this Julia set slow. This is for introducing the material. We will start with this, show what we can do with these Jupyter notebooks, and after jumping into exploring Shiny, which is the first application where we'll be digging. So this is the idea. Imagine that I will like to present for my audience a small lecture on Julia sets. So I have here a little bit of the math with the idea that those objects, those mathematical objects, I created by the boundaries, the sets that are unbound or bound for this equation, given a certain complex number A and all the elements in X. X is a complex number that you start operating over and over and over. And if the resulting of that iteration escapes, goes to infinite, as mentioned here, well, that is the unbounded set, and the other set where you operate over and over with this function, and it remains in the region, so it will never escape. Well, that is the bounded area of the Julia set. To express that into a plot, to actually doing that, you can do it by hand, but it's a pain. So nobody do that today. So what you do is to program the computer to explore Julia sets. All those are collections. So changing the value of A will create an entirely different different plot. So that's the interesting thing. That is why introducing this. But here you see I'm putting the math. I keep it short. And now what I would like to do is to create some code that will produce the Julia set. So in Python, here, the first thing that you do is to import some libraries. I imported two very common libraries in Python, which are Numpy, which is a library specialized for everything that has to be with numbers, numerical, especially with arrays, matrices, all that sort. So arrays of numbers. And Numpy is the solution for that. So it's basically the foundation of almost all numerical packages on Python. So everything that really needs to use many numbers. That's one thing. Another thing is that at the end of the day, Numpy is not written in Python. So all the processing that you are doing is going back into some libraries that has been written since the 70s, 80s, most of them. So those are linear algebra packages, BLAS and LAPACK, that haven't been around for 50 years. They have been very well optimized, and there are implementations of those routines that can take advantage of multi-core. So they were very efficient. By the way, the first thing that I will do in here is just a straightforward implementation of that. It's not the most efficient, but we will come back into what this is not the best solution later. So for this, I will be executing this box in Jupyter. So here, all you have to do is to select this box and press Shift-Enter to execute that. So you see now they have number one. So we have imported the first package, Numpy and Matplotlib is a library, the standard library on Python for basic plotting, for two-dimensional plotting. So we have imported that. Now, this is a way in Python to define a function, a method. If you think about classes, and an important thing here is the use of, well, for some things we can call the method, function, well, that is the or structure, and that is how you define a function that receives a certain number of arguments. Here they will be deciding the size of the box where I will be plotting the image, and the maximum number of iterations. By the way, we are not capable of math here to do it to the infinite. So we need to cut the number of iterations, the number k here, the number of iterations that we are doing this function to verify if the element has escaped that particular x, that particular complex number x have escaped or not the region. That's one thing. So that is here max iterations. So the next thing that I will be doing, and this is Numpy, this is the first thing that we have with Numpy, is creating a grid of numbers, so like a mesh for all the numbers that we will be using here. So it depends on on our number of pixels, the number of elements that we will put in the height, on the width. So we will go from minus 1.4 to 1.4 minus 2.8, 2.8. That would, so 1.4, 1.4 in this direction, 2.8, 2.8 horizontal. That. And as I told you, all those Julia sets, so there's a collection of the mappings that we can do, those boundaries, depending on the value of a, which is a complex number again, that we start with, that we are using here on this equation. So change the A, you will get something completely different. So now that is what here I am defining. I am fixing this value. And here what I will be doing is filling an array, creating an array with zeros, and putting that to the maximum of iteration. So what we will be doing is going and reiterate to see if the elements have escape. If the elements have escape, we will mark those, and they will be showing at which point they escape. And with that, we will be using some coloring to get the figure, that we will see below. So here, this is the part that helped me to show, even if this workshop will not cover Python, let's say from the very beginning, I have some materials. I probably will tell you where you can download some workshops that I have prepared for more basic workshop or tutorials on Python in covering Numpy. And one of the important things about Numpy is to do it well, to try to minimize these kind of things, try to minimize those loops as much as possible, because they are extremely inefficient. So Python is not a particularly efficient language. It's very easy to write, not particularly fast, but if you use the capabilities of the libraries, and those are skipping the Python side and go directly into doing linear algebra or doing operations with big arrays on their own, is the whole reason for using libraries like Numpy. So here we are using Numpy, but we are still doing a loop in something like a beginner will do. So if they don't know the more advanced techniques for Numpy, they will probably doing that. So what I will be doing is going into all pixels horizontally, and after all pixels vertical, and exploring all the values here horizontally and vertically, and checking the operating with the function, with this function here, over and over and over, to see if the value escape a circle or radius 4, or radius 2, actually. If that is the case, there is mathematical proof that the elements that reach a radius bigger than 2, those have no hope. They will escape. If you iterate with that, with this x value, you take one x value and you run it and run it. If at some point it reach a radius of 2 or more, no hope. The iteration of this further and further will just put this value further and further away from the center. So that is we will belong to the unbounded set. So that's the idea here. We are iterating here. We are taking the value here. We are computing the square of this complex number, adding a, and if the value escapes, the square root, the square of the result goes beyond that. Well, that point is divergent. No hope. We will mark it, and with that we will get an array with all the numbers and the value at which they escape. That is an integer that will escape. So I will be executing this box here. And after this box here. So it takes a while, again, because this is the slow implementation of this. But you get this nice figure. They have features all the way to the infinite. If you go and you zoom in, and there are places around there you can see zoom in. There are a rich beauty hidden in this mathematical constructions. But the point here is, we have created with a Jupyter notebook something that presents the theory, presents the equations. By the way, those equations is just for use. It's just knowing LaTeX. If you write papers, you most likely are familiar with LaTeX for writing the papers. I hope so. And that's what you are using here for the equations. That's one thing. We have the code and we have the results. Now, the first element on the interactivity here. So here at this point, yes, it's good material for a lesson, but let's say how I interact with that. So at that moment, you have to tell your students or the users, oh yeah, you can explore more things if you change the value here, A, and the real part and the complex part, you change A, both real and complex. If you change something like 3, and here you put like 5, and you re-execute the box, and you re-execute the plotting, well, you will get another figure, another instance of the Julia set. But you have to tell the user exactly what to touch, and people will be constrained. Well, let's say in certain circumstances, you don't want people to get overwhelmed by the code, or you just don't want to show the code at all, because the focus is in some other parts. So you just want to put the user in front of something that allows them to change the values that you want them to explore and hide all the machinery behind. So that is what I will be presenting today, especially Shiny, because it's the most powerful of those things. And that is exactly what I will be jumping here for the first session. So let's go here and click here on Shiny. So at that moment, what I was doing is exactly what I was presenting here. We have, and I will not be using this, you organize your desktop the best that you can, this virtual desktop, on Thorny, such that you have like a terminal on one side and the web browser on the other side, probably making the web browser a little bit bigger. And let's start creating our first application, our first Shine application. That is our first objective, is to create an initial application for us to explore. So here are the instructions, how you reach that point and how you can load Python. So you get Python. By the way, if you want to check that you have the right Python to here, well, just type this and you should be observing Python 3.11.3, which is one of the latest versions of Python. At least the last time, a couple of months when I update everything on the class. So that is the first one. We all have Python. Let's create our first app here. So I will be creating my first app. I will put it like this. My app. And so the first step, if you go here, you have here, well, I create an app 1, but I will be using a different name here. Type this command there. Shiny space. By the way, in Linux or Unix, the commands, when you are typing on the terminal, they have to be the same case. Lowercase is lowercase. Try to change that and you will get something like, you try to do something like this, command not found. It has to be like this. Spaces are important. The number of spacing is not important, so you can put many, and the dot is important. So with this, we will be creating like a template of a Shiny application. You hit enter, and it will tell you that your Shiny application has been created, and the name of that always It must be app.py. So you have this. Well, it's a little bit. You just get one file here. This is the first. Now let's start executing our first Shiny application. So you type Shiny and run dash, so like minus reload here on this location. That will open up or well do some, let's call it magic, and you can now open your browser here, go here and type, you can type that this way, localhost column 8000. With that, you get your first Shiny app run. So the nice thing here, and this is what we will be exploring here for the next hour or so, is how you build those things. And later you will return, we will come back to the Julia application, and we will using a few of some of the elements that we learned to make that application, hiding all the code and presenting some interactivity so the user can change a few things with that. So if you want, you can change here, and you see here on the bottom that the code, there are changes happening here based on what you are doing here. So that is called reactivity, which is kind of coming outside what you learn when you are learning programming, especially for scientists, that we are used to concentrate more in the algorithmics and the numerical analysis. You took courses on numerical analysis or computational physics or that sort of thing. Well, we are not used to this sort of things, which is buttons. But now there is an interesting way, and it's very simple. Compared what we used to do 20, 30 years ago, the way you have to really start putting a lot of boilerplate code just to get something simple that make like a small ball moving on a ramp or something like this. So now it's super simple. Just you will see the size of the code. It's extremely small, and is capable of doing amazing things. This is simple. And let's explore a little bit what this code, how this code is as, what it is. It's just one file, and it's very small. All this, to create this, just this small code that is importing some Python packages, more here, and is divided in 2 sections. That's all that it is. And all Shiny applications work like this. No matter how big, short, for most part, they are like this. You have the user interface, and there are default values for many things where you get the layouts automatically created for you. If you want, we will see there are ways for refining and making very complex layouts. I don't think that we will have much time to devote to dig into that, but at least you can put those elements and it's just one line of code. So this first title here is just one line of code. This slider here is what is you see here. We will go into all this step by step. So something that receives here a character n, and it's telling me, okay, goes from 0 to 100, and the initial value when I run this Shiny app is starting from 20. And an output here, something that is changing, something that is produced based as a reaction from interactions or changes that you introduce on the slider. It means when you move the slider, it will trigger a function that will happen in a minute. And that will produce a text that will be seen here back in this side of the word. If it's just this, here's this portion here. By the way, right now it's not running. I kill it. It's still there, but it's not running. That's one thing. So all the user interface is just calling a function like this, page fluid. We just will stack the elements one after another in a small way, but relatively simple, straightforward. And all the magic, all the computation, all the things that really are operating behind curtains are on this server side. So, by the way, the user interface is created on the client, so on the browser. This you see here, I think you can inspect that. This is pure HTML, if you are familiar with that. So what it's doing is it's not an applet, it's not creating a heavy interface. Everything is returning as HTML. So you can go and see all those elements. You can dig here. This is just an H2/H2 that, yeah, everything is translated into a HTML. And what happens here on the server is happening on the server side. So if you really need to do some extra math or something, all that is happening on the server, not on the client. So here, what we have is a function. This is a function in Python. It has something that is a little bit more advanced. We just discussed that in the workshop for Python at the very end, which are decorators or things like that. So those are called decorators. Those are ways of putting like a function, wrapping another function. So they give them some extra functionality that is hidden from the definition of this one. In particular, what is happening here is that it's exposing all the reactivity that comes from input. So the changes here, such that this function is called when it's needed. It's not something that is repetitively running and running and running. No, it's just waiting for a change, for example, on the slider to trigger an action, which is refreshing the content of the text. And this text here is refreshed based on or calling the txt function, which is this one. So this value here has to match this name here. So this is the name. This is not just text. It's just the name of the function that will be refreshed, that should be refreshed when the slider is moved, is changed, and it will take this, will take the value of n that has changed, will operate with that, and it will produce, well, the square of the value as a string. That is what this is returning here as a string. And I think this code works only on Python 3.6 and beyond, but Python 3.6 is old now. So you most likely have 3.7, 3.8, and the standard basically is to have at least Python 3.8 for these kind of things. So this is our first application and that's roughly how it works. We will start incrementally adding things, learning how you change, and that's how you learn these kind of things. It's taking examples, start applying small changes, and you learn because, well, the library is rich. So there are many user interface elements. You don't learn this like reading a dictionary, or that's not the way you learn this. The first thing that we'll do is to start changing this application. So that's what I'm doing here. So you see, I put my layout and I got my first Shiny application running. And is this, so here you have the code. and I will start adding things to this application. So the first thing that I will be doing is to move down here, and I think go here to the next application. Is in my code is I put them in order when I am progressing with the material. So is this is what is pretty much the same. I'm having here my title. Now I change that for having two sliders that I will be naming A and B. This one is A. They will have this character. I will see that A. That goes from 0 to 100, and the default value, the initial value, will be 20. And that's it. So, and here the text that is produced at the end. So let's run it. It's again Shiny, run, reload. What I'm doing here? Oh, I think I was not expecting that. Yeah. Okay. Okay. Yeah. What I'm thinking is that someone else, when I request the machine, I request four cores, and someone probably is running with me this. So you got the Shiny app associated to the same port. So what you can do is port and try a different one. So for you it failed, it's just that the port was taken by someone else, and for this, well, it's to change the number of the port, and you get the code running. Okay. So now this time, as I told you, let me see if I can. Well, here I have A. I have the initial value on 20. I can change here, and I'm doing here the sum. So the first change will be that one. Okay, so that is our second application in Shiny. Now we have two sliders and one box and one text box. That's what I'm doing here. So here, let's recapitulate here what we have. This app, all these names are mandatory, or at least this one is mandatory. This has to do APP always, otherwise Shiny will not recognize. So this is an object of this class APP with the R uppercase, and we receive the user interface elements, which is a function here that we call this way. This is a function, and this is a method, or this is a routine, a function that we offer. So you have to offer both. That's one thing. Another thing is that this txt has to match this function here, and this function here has to receive a couple of decorators, at least those two. There are several renderers, and we will explore them in a minute, the different renderers available. But for text, something like this text, including this text verbatim, the decorator associated with it is render.text. So that's one thing. And this is a modern way in Python, I think starting Python 3. I think it's 3.6, where you can do operations inside the text and just with the name of the variables. So this kind of model, but has been for a couple of years, for a few years now. So it's not that new. So that's it. This function should return a string, one string. That string will be used by this user interface element to display the content on the corresponding box. So that is. So now let's go to the concept here of reactivity. So you have this changes here. If you reload here, this change here, or this computation is happening just once, and is only recomputed if you trigger a change with the movement of the slider. It's not that it's computing every 3 seconds, something that you will be doing for beginners. What you do is you reload every 3 seconds, you put in a sleep and you reload. This is stupid, but it's crude and simple and easy to code. But in this case, no, that's not what is happening. This computation is only taking place for changes on the user interface. So that is efficient. So let's go kill this and move on, because the time is running. So layouts. Let me see. This is one example with far more things that will. The thing is, I think is number 3. 3 example layouts. Yes. So you run this and you reload here. Oh no, wait. Okay. So this one is just to give you an idea how you can create far more complex layouts, beautiful. And this is a typical one where you have a few things here on this side of the world. So you have a left panel, and the figure or the changes for the user to see are on a bigger panel or a plot where you have all those changes, and you can here, for example, change some ranges with the slider. The slider support also ranges, and this checkbox here, or this circular box here, can change in this case the color maps used for what you have on the right. And let's now review a little bit how this Python, this Shiny app works. So you have here the user interface here, and you have like cascade or functions inside functions that will encapsulate the user interface elements. So the first one, the outside, is a fixed box, a fixed page where you have the first text, some markdown code or text here, and a sidebar. So this sidebar will be all that is inside here. So all this box here. And this box, we will split that in 2 sections. That's what we are doing here. The first sidebar that will contain the radio buttons and the slider. And in the other side, the main panel here is just a plot. As this is a plot, the output is a plot, the decorator, the render decorator, is the render.plot. So there is text is the decorator for text, plot is the decorator for plot, and there are several others that we will be covering them. And here is the plot. It's a very simple plot, something that a more normal modern computer can do very quickly. And what we are doing here is changing the color map based on the values here of the CMAP, and CMAP is this radio button here that receives a dictionary of values. So people will see this. The code will send the key. So the value is for the user, for the final user of our code. The key, this is a dictionary, so it's a key value collection of elements. So this is the internal name of us, of the color map in Matplotlib. And this is another color map, and this is another color map. There are many, by the way. In Matplotlib, there are 4 collections of those. Selecting 3. This is what the code actually needs, or what will expose here, depending on what the user is clicking. That's one thing. And here is the minimal value of this slider, which has the name range. This is the name, the identifier for the slider, for this user interface object. And this is the name that we offer to the user on top of the slider. So it's color range, and it goes from -1 to 1. And if you put here a tuple like this, it means that this should produce as a value an iterable, so with 2 elements, the right and light, or right and left elements, so 0 and 1, and that's what we are doing here. So the range here, the first value will be the minimum, and the maximum will be here. So with all that is controlling what we are using here for this routine in Matplotlib. And we have that. We put the color bar, which is this color bar here. This is Matplotlib, is right here, is this bar here. So this here, what you see here is a Matplotlib figure that is inside of this main panel. And here on the left panel, you have the controls that will change the behavior of your application. So now let's see. The purpose of this is to demonstrate that you can organize this in a more rich layout. You can have even tabs and descending menus. There are a few things. There are many things that you can add later, but that will be kind of more advanced. So I will be just presenting very simple layouts that usually the flows. Well, that's what we have for this. So this is like an schema of how they are presented. I just removing all the code here so you can concentrate on how they are inserted, how they are inside some other layout. So have fix, you have the 3 elements here: the text, the title, the markdown, and the sidebar, which is covered the whole area below, and that will split in another sidebar on the right and on the left, and the main one on the right. That is the structure. So now let's explore a little bit the input elements here. So we already see this, so we can pretty much run it quickly. So I will be killing this, and I will be going to number 4 to run this one, and it's this one. In this case, for these examples, we will not be having any reaction. So it's just for showing you the different things that you can do here. So they are not doing anything. So you have here rangers, you have here sliders, and you have here a box where you can increase or decrease a number. So for numbers is that depending on the initial and final values, this will return integers or floating point numbers. So you see here, here on the code, you have the slider, and if you put here integers, it will return integers as the value. And here I have, well, okay, here, the sliders and the range sliders. And here I am putting none for the server. So the server is not doing anything. It's just for presenting what you can do. If you need numbers or ranges and you want the user to change the values, numerical values, this is something that is one of the main things that you will be doing if you prepare an application like this. So put in some numbers. So let's move on. And let's go to number 5. And let's run this one. This one are 3 different, well, actually 2 ways of presenting text. So this one here is a text box. You can click whatever you want. This one is pretty much the same, but now you have multi-line. You can type and it will respect whatever you are writing. So if you need to insert some text, that's what you can do. And you can all this is all this is HTML, so you can go here and stretch a little bit the box, and here you will see something that could serve as a password. So which is, it looks like a password, but they don't have the protections. You need to be careful that this is running with SSL or some protection. Otherwise, even if it looks like a password, the elements that you send to the server are plain text. So there is no security on this. Okay. What else? So those are the text inputs that you have. Selections, and there I put all of them. So now let's go to number 6 and reload this one. So now here I create this one for several options that I have. So imagine this one is when you want to select just one element. Here you are presented with multiple options, and you just click on the options that you want. So is multi-selection, and here same thing, but in the first case is pure HTML, and the other case I need to check it here. So oh yeah, the first one is HTML. The first one are JavaScripts and library, selectize, and the second one, input select. This input select, those are pure HTML, and they recommend the first one, the selectize. So those are pure HTML. Here you can click, I think, this way. Multiple options. Okay, so you can select several of them, and if you want just to select one, well, there is also this option here for radio buttons where you can take one selection, or if you want, you can click multiple options here, like check boxes. So all those, when you have like a dictionary or a list, and you present those options, you will see the code. In this case, the choices is a list, so it's an iterable. those will be used as the text, and the text that is presented, and the element that they will return for the value. So that, and here, if you select multiple equal true, well, you can click on several. So that's the whole point. Now this one. So let's kill this one here. Let's go to 7. Okay. So just one where you click the box, and this one that you can use to trigger an action, something well, something active will happen, like a switching. So it's this is more like a fill in the form. This is more for triggering an action, some clicking, some plotting, or changing some table, or doing something, doing some transformation to some data. So those are more inputs there, and the toggles here. And okay, the date is the next one. It's number 8. Okay. So here, if you need a date, you can fill it this way. It will open an HTML tiny box where you can change the year, you can change the month. So a very convenient way of selecting dates and or select ranges of dates. So here and here. Okay, let's move on. This one is dates here. Okay, so a date and a date range. Okay. Now here we have 3 different buttons, but actually 2 variants of one of them. So all those make sense. For example, if the calculation that you are doing or whatever is happening cannot take place in real time because it takes a few seconds for processing something, or you need to download something over internet for the manipulation. So you don't react immediately, you just wait and ask the user to click something like calculate now, or ready, or okay, or something. So all those are buttons, and this one is a particular variant of the first button of this one, where you put something in red because it will trigger an irreversible action or something that calls the attention from the user. So the code for that one is right here. So you see this one is just normal action button. This one has a little bit more like the blue with pop-ups, a little bit more, is more visible. And here, this one is colored in red for calling, and all that you have, the difference between those 3 are the class. Here you put something like the primary button, and we put a danger button, and this is just a text that is like a link, so we will trigger something, but doesn't have the contour, or it's just some link. So now all those that we saw up to now are the main inputs that you have. So with that, you can create a form like we did before with the color map, where they have all the elements that you want to present with some interactivity, and with them you have the application that will change its operation based on the different values of those elements. Now we will explore what are the output, the other side. You have the input, and now we will discuss what we can put on the other side, on the output. Okay. So in this example that I produced, I now have one simple slider, or one text, one slider, and here I have a plot. So I have a matplotlib, very simple, you will see, and all that I'm not doing here is changing the number of random points that I will be creating. It's a Numpy, it's a Numpy array with 2 dimensions with all random numbers. So you can change is creating a different randomization of them, of those values. Okay, so the code is very simple here. It's this one. It's 10. 10. Yes, this is 10. Yes, this one here. So let's explore a little bit what this code does. So we have we already know this. So this portion should be understood. Now you can explore on your own. That H2 is just the text. It's with an HTML put on top as header 2. So it's a little bit smaller than the big one, the H1. The slider, and we put, this is the identifier. All the inputs, as I mentioned before, they have at least those 2 things: the ID, the name of the user interface element, and some title or something that will be offered to the user in the layout. And this one, those are optional. So I am putting the value, the initial value, minimum, maximum, and the steps that I'm jumping when I move with the slider. It's not moving 1 by 1. In this case, I'm moving 10 by 10. So now, and the output here. So this is what we are going to concentrate in the output. In this case, the output is a plot. The name of the function that we'll be plotting is this, a scattered plot. And here, this is the same function, has to have the same name. It receives this decorator. All of those receive the output decorator. This one in particular receive render.plot. So pretty much the same name that you have here is the same name that you use for the decorator. So if it's output plot, the decorator will be something like render plot. What is it expecting at the end? A matplotlib figure. And to operate, it will use the value that it receives from the slider, from n. So I am using it twice here for creating two arrays with this number of values. So this np random rand will create that, and this is a matplotlib function for putting a scatter plot of those values there. So that's it. It's a very simple Shiny application. Well, one input and one output on plot out. So that's one. Now let's move on to the next one. Here. In this case, this is what I have. For those who are familiar with machine learning, this is something that is familiar to you because it's an academic example that we often use is the iris dataset. So it's a table with 150 elements. So you see here how this looks like. it's a CSV file. It's like a table, and someone more than 100 years, I think 100 years ago, something like that, measure the 4 characteristics of the flowers, or 3 varieties of flowers native of Hawaii, I think. So the sepal length and the width and length of the petal and the width. So 4 numbers. So those 4 numbers here, and they are identified with a certain variety, or I think yes, a variety of certain species of flowers. So they have three variety, three kinds here: Setosa versicolor and Virginica. So all the, and this table is often used for making examples about classification with the different techniques available in machine learning, for example. So my purpose here is to design a Shiny application that will just present the table. That's for presenting the table and to the user. This one, I think, uses an extra package. I think I mentioned it. This requires pandas because I will be importing the table, the CSV file, as a pandas data frame. Pandas is a package for data analysis in Python, and Jinja for the production of the table. This is another Python package. And I think I have it. No, I'm not super sure, but I think I have it. Let me see. So, oh yeah. So here is the table. So it will take the CSV file, it's reading the CSV file, and it's presenting me the whole table, a nice layout, nice displays of all the values there. And so that is what this output is producing. So it's called table. We produce an HTML table. So if you see here, this follow the same theme, output table, and a function, and the function is decorated with this render.table decorated. So, and here, what is returning is the data frame. So it uses the data frame, the pandas data frame, or something that could be converted into a pandas data frame. So there are several methods around 2 pandas, and if you can use that, we use, well, the quack paradigm. If it makes quack, is a pandas data frame, it will behave like a pandas data frame, is a data frame. It will convert that into the object, the correct object, and it will expose that object. So it's the data frame with the corresponding tables, the names of the columns, and the values nicely displayed. So that's what this output is producing. And now let's move on. And now interactive plots. And I think I have this. I'm not super sure if I end up installing. So this one is in number 12. And oh, I forgot to install it. But I think I can install it. Let me see if I can install it quickly. I probably will install it because this is important. Okay, so I will be I will check my time. So and this one here. In the meantime, I think it's installing. Let me see. And I think this one is there. Oh no, okay. Oh, okay, I need those. So this one, in this case, this is even more, this is nice. So now we are usually matplotlib. Well, we create a plot, and that plot is static. You don't interact with the plot. This is what it is. And now, but there are other libraries that allow you to interact with the plot, changing ranges, doing zooming, exporting the plot. And one of those packages is Plotly, this one here, Plotly. And if you want to use those interactive widgets, and Plotly is one of them, you need to install this extra package. That's what I'm doing here quickly to get that. So now it's on Thorny, and now we can use it here. So we'll be killing this and reloading this one. Okay. Okay, now, yes. So it is the same data set, the data set that I was using before, the iris data set. Now, this time, what I'm doing is plotting the histogram of the values, those values that you saw on the table for the 3 different species, identified with different colors. So you see that 3 different varieties of that flower. So you see the distribution in the sizes for those, one of those 4 values, the elements there, the measurements of the flower, length, width, and how they are distributed. So in this case, the beauty of this Plotly is that you can make like a zoom here. So those plots, you can interact with them. You can, well, you can return them. You can export this. I think you can download the figure as a PNG file. So, and it will show the different values that were present in the table from those the histogram was built. So they have nice features. You can move in here to the right, to the left. So that is a more interactive plot. Not everything that you can do with matplotlib, you can do it with this, but they have nice features like that extra interactivity. You need those extra 2 packages, Plotly and Shiny widgets, and you can get something like this. So you are adding more interactivity to the output side. That is why you need some extra package, because here the output is also interactive. So that is that side there. And this one is cool too. Let me see. I think I need internet for this one. I'm not sure if I will be able to display this one. It's number 13. Oh, I need iPad. Okay. I need. So here. Okay. What is the name? Okay. Okay. So this one here, now. No. Let me see if yeah. That's what I was. Yeah, this one will not work because I need internet access and the compute node doesn't have internet access. And so we will not download. But the cool thing of this one is that with a machine that has internet access inside. So if you are using this on your own computer instead of or a compute node in an HPC cluster, it will download the map, several visions of the map around Morgantown, so the Mountaineer area, and you can see the streets. That's the idea of this. But yeah, I was imagining that it will require internet access for downloading the maps directly during execution. So now let's keep it this one here. Now let's move to 14. Which is the basic example. So this one is what we already saw before, the simple text. That is not super interesting. We already saw this one. And the only thing here, oh yeah, is the verbatim one. So there are two versions of this, two output. One is output text and the other is output text verbatim, but they share the same decorator, which is render text. So here I have a very simple example where I'm just putting the text on the screen. And here I am just taking an entire text that I would like to keep it with monospace casing and more like a code. And it's in 15. So like this, what I'm taking is the documentation from one function here and in SciPy, and I'm just expressing that, and it's just fixed text, it's code or something new. I can read, for example, a text file that has some C code or Fortran, and I will be able to put that with a fixed font, like a code. So those two, they share the same decorator. And let's okay. Now this one is 9. So it's 16. Okay. So this is the code. Let's see. So I have an input text. This is from the input. I have here the checkbox where you can select multiple options here. And here I have the select eyes where you can select just one of them. So the size of the font, this is just one choice. But here you have multiple choice. You can select 1, 0, or both. And this is the output. And the output is an output UE, user interface, and the render is render.ue. So what I'm doing here, what this is expecting at the end is HTML code or a shiny UE object. So there are 3 things that this could receive. The output will put in place when you operate with that. It could be a plain text, could be HTML, or could be a shiny user interface object. So you can create more objects or more layouts as a result of interacting with another user interface element. So in this case, it looks like this. You have the text. So you can change something like this. It will trigger a change in something like this. And now you can change here bold or italics or both. And you can change the size into H2, H4. You can make it smaller and smaller. So all those things that I'm doing with one single selection. Here is something that I could select one or more, is changing something. So same way you are changing actually HTML code. So this element here, if you go and inspect it, it will take me out a little while to go into those elements there. Wow, that one is around here. So this one is here, and it's an HTML, and it's basically changing that and put an H4 here, and I've click here. That element here is changed, and you will see that it's putting inside here in the HTML. It's putting H4, it's putting emphasis and strong, so it's adding inside the HTML code all the elements for making it strong. Well, so you see, at the end of the day, is a powerful library that is changing HTML code on the fly for a web application. So we click this one here, and I think we can move a little bit into the server logic. And with all what we learned, we can go back and try to see what we can do with our Julia sets. That's the idea. So let's see, this one is 17, just for getting an idea on how this works. This is just very simple at this point now, to see that we can trigger changes on elements or output elements here by interact with that. How that works, as we already saw this, the code is very simple now. So you have the user interface, this function here. Page fluid, which is the usual thing when you don't have too many elements. It will create one element after the other. So it's an input box here, an H3 text, and here one output, text verbatim. Here we have the render text, the output, and based on the value of the input here, enable, will return a boolean. So if yes, it will put and return the string, or not, it will return no. At the end, you need to have this exactly as it is, app being an object of the app class, and you offer the user interface and the server, and it will create. So now let's go and explore my Julia the first one here. Okay, this one. So I create here my, let's see if I can see my app here. Let's see, stretch this for a moment. Okay, so here is my code. It will produce the Julia set, all the algorithm that is running here, even with the extra loops, is happening here, is part of my function here. This is a plot. So what I will return it at the end of the day here is an IM show, which is a figure, it's a matplotlib figure produced here. And so my render here is render.plot. My output on this panel is output plot. And the function that will be triggered when I change my user interface is Julia plot. And that the kind of things that I will be changing here are three things: is the real part of the number, and I will put a slider that will go from -1 to 1, and I have my initial value here that will produce the first Julia set that I present in the notebook, and the steps, how I am jumping. The second slider is changing the imaginary part, and the third element here is changing the number of iterations. If I don't put a very high number of iterations, you will see that you get like a crude representation of the Julia set. If I raise that value, I get more features. It will go into more the control. It will be far more precise into the description of the nuances of the Julia set. So all that is something that I would like my users, my students to interact with, to change, to explore. Those three things. I will hide the entire code, the source code, from them, not because I don't want them to see, it's because I don't want it to be overwhelmed by that, and we'll concentrate in some other parts, more the discussion around the mathematics happening, not the actual coding. So this is the code. I will return here and change it. So leaving this, and I will launch this application. Okay. So you see here the box. This is small, but it demonstrates what I'm doing. So I can change this value here, and it will recompute the Julia set. So if you want, the boring one is around 0, I think. You see more symmetric, almost symmetric. So this one you get like a circle, almost a circle. But you see it's slow. Why? Because every single time that I'm changing the sliders, it's almost a circle, because I'm putting the two elements A and B equal to 0, the real and imaginary part equal to 0. But it's recomputing, so it's slowed. So that gives me the opportunity to show why this code is slow. It doesn't need to be that slow, but that's more with the Numpy operation rather than the shiny thing. So I will keep it like this, and I will present the other part here. Also, by the way, I would like to express here what happens when I increase, for example, the number of iterations. It takes longer because it's doing this for every single pixel there. But you see, the contour is to the limitations now of the pixels in the figure. It will go and recreate with a big detail all the contour of the Julia set. So now, this is the original code. And what I would like you to focus your attention here is on, let's put it with bin here so you see the coloring. So let me see if we can extract a little bit. What is the problem with this code? Why this is slow? And this is more into the part of my lessons on Python. The whole problem with this is those 3 loops that you are doing here. So you are basically going to your array. Your array is this. Your arrays are those 2 arrays here. So the values of this here and Z that you are going into all the values one by one here and here and operating as many times as your max iterations for all your max and doing the same operation. How you can do better than this? Well, instead of putting this into the shoulders of Python, you can translate that into Numpy operations where you are removing all those two. So you're just operating with Numpy with an array. And if you are using, and most likely you're using a Numpy that was compiled with a good implementation of BLAS and LAPACK, you get at least one order of magnitude the speed up on this operation, removing those two loops. That's exactly what I will be doing here next to show how I can get in my Julia fast. It's Julia fast, exactly. How it is. So I keep the interface exactly the same, the sliders and the number of iterations. Yeah, now notice that this time I only have one for loop. Actually the internal one, the loop or the path that we are doing across all the pixels horizontally and vertically is happening implicitly here, and it's Numpy who is taking care of that. So it's doing this operation for all the elements. Here I need to have an extra array that is collecting those that are already diverged. So I will not operating with them anymore. So I will just storing those elements that have not diverged. So there is an extra variable here, but this is much faster. So let's see. This is an important lesson on Numpy, so that's why I put it. So let's make some space for my application now. So you see, it's almost immediate. You takes no time to recompute the whole thing, even if I ask the 100 iterations. So you see that it's really speeding up the operation. So that's another thing that is important. At the very beginning, you get something that works, that gets the job done. But when you start thinking in interactivity and not optimizations comes into the game, back again. So at that moment, the message here is try to minimize those loops, try to go as close as possible with the things that you can do, for example, in Numpy for processing the data or pre-processing the data in advance, so such that what you are exposing to the final user are just data that has been calculated, that we have results. For example, imagine that you train a neural network. For those who are attending the GPU workshop, we saw one neural network that is capable of identifying photographs and knowing what they are. Well, after the neural network has been trained, the execution of the neural network is really fast. So you can just having something that upload the file and then will identify the object or something like that. Is okay. So with this, I will have a little bit of time to introduce the IPython widgets. I would prefer to give most of the time for Shiny. I think it's what many people could be interested in using. So that's why I put more emphasis on that one. So for the Shiny, for the IPython widgets, let's see, I probably this skill because I just asked for 1 hour. So let me create, yeah. So this one was 1 hour. So I will be recreating another Jupyter notebook. So click here. It will be Python, standby 1. Okay, 0 GPUs, Jupyter Lab, launch. Okay. Okay, this one was my previous version here. I will open, let me see, start with this one. This one is simple. What I'm doing here, this one is using IPython widgets, which is this packet here. And I will be just exploring the easiest thing that you can do with this. And this is for Jupyter notebooks, by the way. So instead of creating a web application where you need to launch a server, and by the way, there are ways to put this like in AWS. And a few years ago during COVID, one of my colleagues, Daniel, he put this something for the National Guard, if I'm not wrong, for related to the COVID situation here in West Virginia. So those things have applications in real life. So, but this one is more for adding interactivity to a Jupyter notebook. So we are going back. I am, for example, teaching my students about the quadratic equation, and I would like them to explore what you can do with that, what happens when you change the different values, A, B, and C, how you solve, what are you doing when you solve an equation like this, or if you go into a polynomial, which are the characteristics that you can see from those elements. So all that I'm doing here, well, I am importing Numpy, the traditional Numpy, Matplotlib, here the IPython widgets or Jupyter widgets, they are called that way too. And here I'm defining my quadratic functions. It's just something that produces a plot. And I would like to create something here that start just by moving those sliders. Adding, so you see, if I keep a 0, it's just a linear function. If I just add this, now you start adding the quadratic element. So you got a parabola, and I'm changing here so you can show what is the effect of the 3 different constants in the quadratic polynomial. So that those are Jupyter widgets. This, in the simplest way of presenting those, all that you have to do is to have a function that receives multiple arguments, 3 arguments here, having and create and call this interactive here, that is part of the IPython widgets, and present the function that you want, the values of the 3 arguments that you have, and the ranges that you want to explore. And with that, you create the object and you just show the plot with those. So there are more things that you can do. but the time for this one, we will not have time for explaining that. I would just like to close this presenting a very, very, very simple example of the IPython widgets. And by the way, there are ways in which you can combine both things, Shiny with IPython widgets. So, but that's beyond this. So just for you to know that this one, even if I devote less amount of time for this one, is something that you can also integrate with Shiny. I think we have time for entertaining questions if you have one. I think this is all that I have, at least that I would like to present today. By the way, if you want to use something like this at home, because there is no reason why you cannot do this on your own computer, we are using just the cluster because it's convenient. And you are, for example, a Windows user, I recommend you to install something like this, Anaconda. There are versions for, well, it's here. It doesn't need to be, well, it's changed. It's because I am a Mac, but they have versions for Windows, Linux, Mac. With Python 3.11, exactly the version of Python that I'm using. And with this, you can install all the software that I present here, Shiny, the IPy widget, the IPython widgets, all that, and you can run these examples on your own at home, and you can create your own applications. And there are also ways, once you have, for example, a paper that you want to promote somehow with an application, allowing the readers of your paper to go to your website that could be running on AWS or something and explore the data or reproduce or manipulate your algorithm and play with a little bit with that. This is something that really, really increases the chances of you getting, let's say, more visibility for your research, and that delivers to you in good things. So that's why I would like to present that, both for researchers and also for people teaching materials. So that's it. So if you have questions, I am open to entertain those with help or clarifications with the kind of things that I did today.